Hi guys, I'm Jim Schuster, team manager for ALeeS RC. I have here with me Charley Stevens, the owner, creator, everything ALeeS. It's all right here with this gentleman here. So Charley, what we're going to talk about is we got both helicopters here. Can you tell us a little bit about the difference here?
Well, right now this is the new prototype running with the stretch boom on here. You'll notice the boom is silver. This is not a production release boom at this point. So you can tell there is a difference when you're measuring against the current released 700 version, which is the black boom. You'll notice that the boom is significantly longer. It's actually 100 millimeters longer than the current production 700 boom. The intended release for the helicopter was to be a 750. So to clear up confusion why it says Rush 750 was because the helicopter was to initially release as a stretch, but due at the time there was not enough product as far as rotor blades, 14S power systems that could provide ample supply to support a product. So we actually reduced the boom and created a 700 series to release first, but never corrected the canopy, which says Rush 750 on it. So in the future, the 700 kits will eventually release and say Rush 700 on it. And we will be moving to a new style canopy, which is more of a wrap style canopy, that will be the true Rush 750. The current paint scheme that's on the Rush 750 canopy, the stretch canopy, will not be this paint scheme. This is simply a prototype canopy with a temporary paint scheme to kind of match, see what we felt about the current paint scheme. The Rotorhead components remain the same. The only changes would be the longer boom.
Tell us about the spindle. The spindle is a little different now than it was when the original design came out. Tell us what you did there.
Well, initially when I released the helicopter, I was able to make a change, and the current spindle that was released in the earlier versions of the helicopter used M6 cap screws to hold the blade grips on. I didn't feel that was feasible for running a stretched helicopter, so I created a new one which has M8 threads on it, and you can actually see with inside there, you can see the M8 lock nut. And I did not want to have two spindles on the market that dealers had to stock two complete different components to perform the same task. And the newer spindle, I feel, is a far better safety margin for running the longer blades on there. To give you an idea, the current spindle, we have a sample here, and we will, so you can get an idea of what the new spindle looks like. This is still a 10 millimeter spindle with an M8 one pitch thread on here. This still is a treated spindle shaft. The significant advantage to this is the core thickness of the spindle versus a M6 cap screw, which has a much smaller core thickness. What I mean by core thickness is the amount of solid material between threads. The newer spindle significantly increases the core material, thus making it a stronger point of connection. So that is the new release. It will fit in both the standard 700 version and the new stretch. Kits today are released now with the new standard spindle in here with the M8 nut. We have phased out the original M6, so you'll no longer be able to purchase those. So that's kind of the new thing there.
What's what's different about this Rotorhead versus every other flybarless Rotorhead on the market?
Well, the difference in this Rotorhead, this is what we call our 2-SIG Rotorhead. It's an acronym for two single input control. Basically, the difference is against the conventional systems that are currently on the market is I have a pitch, phasing, and the cyclic lever system on here. What that means is that the pitch and the cyclic has a direct input from this lever going to the swash plate. This is a bridged lever, so it means it has dual support system. It comes from right here and then goes to the radius arm, which goes down to the swash plate. And what this does is it provides 2 points to add strength to the control system going to the blade grip. And what this does is the current system, this is a Rotorhead that's been completely disassembled. And you'll see it is a machine stud to the side of the Rotorhead. And that stud acts as a solid point. And then the lever that mounts to it, as you can see, there's 2 different size ball bearings on here. And what that does is it provides triangulation to when it's mounted on the stud. And what this does is when you bolt it on there, the 2 different levels of contact surface provides a much more stable lever system than the conventional Rotorheads that use them for phasing. Most use 2 identical size ball bearings with a screw, no post, just a solid screw that goes into the Rotorhead, and the arm can generate pitch or can generate slop in the system over time of use. Where with this Rotorhead, with hundreds of flights on it, will remain slop free due to its design. That is the difference. Now the actual reasoning is most fly barless systems have an average of 20 to 25 millimeters from the center of the main shaft to the center of the ball to provide a pitch length to the blade grip. Where on this Rotorhead system, we currently have 15 millimeters from center to center. What that does is it provides a faster response time from a center stick movement. So what you get is a more agile system from a center stick movement. So more for the aggressive 3D pilot that's demanding instantaneous input with quickness and still maintain stability and accuracy due to the 2-stage ball bearing system with the dual support. That's what makes the Rotorhead system different than conventional systems now.
All right, Charlie, one more question we have. I get a lot of questions from guys in the field on the linkage system that we have with the bell cranks. Explain a little bit. Some people think that that's a disadvantage. Explain to us why and how this works.
Well, there's a couple advantages to the helicopter having bell cranks. One is to help save the servos. Generally, loads are equally applied to the servos, and in uneventful, you have a crash. So a lot of times it saves some of your very expensive items, which are your servos. Another advantage is, compared to direct to swash, is that direct to swash, most servos are routed directly around the swash plate. And what this does is it actually makes a negative or a neutral weight distribution amongst the helicopter. And when you have neutral weight distribution, you have to either A, make the helicopter longer in the front to help compensate the addition of neutral weight. By me having linkage rods, I'm able to shift the helicopter's natural weight that it must have in order to fly, which is servos and other electronics. I'm able to shift them in any position I want on the helicopter and not have to make the frames longer to add weight. You know, more mass that you add adds weight to the helicopter. So by doing this, some say, well, this way may be more weight. But when you have a smaller frame, smaller skid tubes, narrower frame, and the advantage is now I can take the weight of the helicopter, which is the most heaviest would be the batteries, and create a saddle pack system. This allows me to bring the weight more closer to the main shaft, which helps control inertia. And inertia is when the helicopter is spinning in a pirouetting fashion, it's less work the tail has to do to stop that weight. So the closer I can make the weight come to the center of the main shaft, the less inertia the helicopter has to have in order to stop. So there's a lot of advantages by having bell cranks other than simply seeing them as an inferior item.
I guess that about wraps it up. Thank you, Charlie, for taking the time to explain to everybody about some of your unique designs and what's going on here. We had some great weather here at the Birmingham event. Lots of great flying by all our ALeeS pilots and other pilots as well. You guys can pick your ALeeS Rush 750s up at ReadyHeli.com. Thanks for watching.